In this video, I'm going to talk about how to solve quadratics using completing the square and by factoring. So for number 1, the zeros of the function f of x equal 2x squared plus 2x minus 4 are, and then it gives me the answer choices. So they're asking us what values of x would get that function set equal to 0. So all we need to do is set that function equal to 0 and pick a strategy to solve. So normally in a regular trinomial, you'd ask yourself what multiplies to -4 and what adds to +2. But the problem here is that there's a coefficient in front of that x squared. So I'm going to use factor by grouping, where I take my a term, my c term, and I multiply them. So 2 times -4 is -8. And I ask myself what multiplies to -8, but adds to +2, so I'm able to split that middle term there. So some factors of -8 are -4 and +2, 4 and -2, and it looks like that's the one that's going to work. So I'm going to split my middle term. I'm going to rewrite the 2x squared, then plus 4x minus 2x minus 4. So 4x minus 2x is still positive 2x, so I didn't change the value of anything here. I'm just changing the way it looks, because now I'm able to group the first two terms, pull out a GCF, and pull out the last two terms, and pull out a GCF. So for 2x squared and 4x, I could factor out a 2x, which leaves me with an x for the first term, and a 2 for the second term. Now, for factor by grouping, when I do this second pair here, I still want to get x plus 2 in the parentheses, so I'd be able to factor that out of both terms. So the problem is, if I pull out, let's say, a +2, I'd be left with -x minus 2. So I wouldn't be able to do anything further from this step. So the strategy to fix that is just to pull out a -2. So when I divide -2x by -2, I get positive x. And when I divide -4 by -2, I get positive 2. From here, I could pull out this x plus 2 from both terms. And I just rewrite what I have left. I've got a 2x in the front and a -2 in the back. Remember that this is still set equal to 0, so I could tee it off and solve it how I normally would, where I set x plus 2 equal to 0 and 2x minus 2 equal to 0. When I subtract 2 on this side, I get x equals -2 as one of my solutions. And when I solve this right side equation, I end up getting x equals +1. So my answer choice for this one would be choice 2. Now, there's a lot of different ways you could solve this if it's a multiple choice question. If they asked me to factor, I would have to go through this process right here. But remember, the zeros of the function are also where the function crosses the x-axis. So if you wanted to graph this just to check yourself, it should cross the x-axis at -2 and +1. And you could either look for that in your graph or go to your table and look to see where those y values are equal to 0. Number 2, if 4x squared minus 100 equals 0, the roots of the equation are, so again, they're asking me to solve an equation where I've got a quadratic set equal to 0, and since it's a multiple choice question, if you wanted to graph 4x squared minus 100 and look to see where it crosses the x-axis, you could do that, but I'm going to show you how to factor here. So I notice it's a binomial because there's two terms, and 4 is a perfect square because that's 2 squared. X squared is a perfect square, and 100 is a perfect square because that's 10 squared. So this is looking to me like a difference of 2 squares. So remember, a difference of 2 squares factors into the first thing plus the second thing times the first thing minus the second thing. So if I apply that rule here, I ask myself, what would I have to square to get 4x squared? Well, to get 4, I'd have to have a 2, And to get x squared, I'd have to have an x. So 2x squared would give me 4x squared. And to get 100, I'd have to have 10 and 10 there. You could always double check yourself by distributing out, doing 2x times 2x, 2x times minus 10, 10 times 2x, and 10 times negative 10, but I'm not going to do that here. So once you get to this point, you tee it off, and you set both parts equal to 0. So when I subtract 10 on this side, I get 2x equals negative 10, and when I divide by 2, I get x equals negative 5. So already I can see that my answer choice is going to be 3, but I'm just going to double check by keeping going here. So when I add 10, I get 2x equals positive 10, and when I divide by 2, I get x equals 5. And as always, you could double check yourself just by graphing this in your calculator to making sure it crosses at 5 and negative 5. Number 3. When directed to solve the quadratic equation by completing the square, Pedro arrived at that equation. Which equation could have been the original equation given to Pedro? So for this one, there's a couple different ways you can approach it. The easiest way would probably be just to complete the square for each of them and get to that step to see which one works. But if you're a little clever, and if you remember from class, that number right there, that negative 3/2, is always going to be the same as whatever b over 2 was. So since it's negative, I can throw out answer choices 2 and 4 right away because they both have a positive 3 in them. So I'm just going to start by looking at answer choice number 1 and just completing the square on that one. So I move the c term over to the other side. So I have x squared minus 3x plus something equals negative 7 plus something. And to figure out what that something is, I take b over 2 and I square it. So negative 3/2 squared would be negative 3 over 2 times negative 3 over 2. And remember, when you're multiplying fractions, you can multiply straight across. So negative 3 times negative 3 is positive 9, and 2 times 2 is 4. So I'm going to add 9/4 to both sides of this equation. Now for the left side, you can think about how to factor this, but you know that it has to be that b over 2 to begin with. And you could check yourself by saying, I know they need to add to negative 3 and multiply to 9/4. Well, I already know that they multiply to 9/4 here, but just to double check that they add to negative 3, when I'm adding fractions with common denominators, I keep the denominator and I add the numerators. So negative 3 plus negative 3 is negative 6, and negative 6 divided by 2 is negative 3. So it checks out. Now for the right-hand side, you could do this in your calculator if you want, but I'm going to just multiply by 4 over 4 here to get common denominator so I can add those fractions. So negative 7 times 4 is negative 28, and I have it divided by 4 plus 9 over 4. Now that those denominators are the same, I could add those fractions. Negative 28 plus 9 is negative 19 over 4, and I rewrite the other side of the equation. So in this case, I didn't even need to check answer choice number 3 because I know that this equation matches up exactly with my original equation here. So if that hadn't happened, I would just go through answer choice 3 to double check that I get that equation. Number 4. Paul correctly used the method of completing the square to solve the equation x squared plus 9x minus 15 equals 0. His first step was to rewrite the equation as x squared plus 9x equals 15. He then added a number to both sides of the equation. Which number did he add? So if you remember how to complete the square, this question's actually pretty straightforward, because you're just looking to see what b over 2 squared was, because that's what you'd be adding to both sides of the equation there. So your b number here is 9, so 9 divided by 2 squared would be 9 over 2 times 9 over 2, and remember, when you're multiplying fractions, you could just multiply straight across. So 9 times 9 is 81, and 2 times 2 is 4. So you get 81/4. Number 5. Solve by factoring. x squared minus 2x equals 63. So anytime we're trying to solve by factoring and we have a quadratic, we always want to get it set equal to 0. So I'm going to subtract 63 on both sides of the equation here. So I get x squared minus 2x minus 63 equals 0. And then I ask myself, what numbers can multiply to negative 63 but add to negative 2? So if I think about the factors of 63, you have 9 and negative 7, or negative 9 and positive 7. And if I need them to add to negative 2, this is the pair that's going to work here. And remember, if you have trouble finding factors, if you don't know them off the top of your head, you can always go into your calculator, type in negative 63 over x, and just take a look at the table. And those will give you all the x and y values that multiply to negative 63. So I write my two sets of parentheses, and I have x, and I just plug in the two factors there, negative 9 and positive 7. I set x minus 9 equal to 0, and I set x plus 7 equal to 0. So I get x equals 9, and x equals negative 7. And again, you could always check yourself by just going into y equals and plugging in x squared minus 2x minus 63, just to make sure that it crosses the x-axis at x equals 9 and x equals 7. Number 6. Rewrite the function f of x equals x squared minus 10x minus 11 in vertex form by completing the square. Alright, so remember vertex form just looks like y equals a times x minus h squared plus k. So we're completing the square here in order to get that perfect square trinomial that we'd be able to factor pretty nicely there. So I rewrite what I have, x squared minus 10x, and I'm going to use these two terms right here to try to get a perfect square trinomial in the front. So I'm going to write plus and a line because there's something I need to add there to make that a perfect square trinomial. And I write my minus 11 at the end here, and whatever I add to the equation here, in order to cancel it out so that the equation stays equal on both sides, I'm going to have to subtract that same thing at the end. So I do the same process that I've done for completing the square. I take my b term, negative 10, I half it, and I square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I add 25 here, and I subtract 25 here. So x squared minus 10x plus 25 factors into x minus 5 squared, because negative 5 times negative 5 multiplies to positive 25, and they add to negative 10, and negative 11 minus 25 is negative 36. And this is what your vertex form equation should look like. Solve by factoring. So for number 7, this is going to be another one of those factor by grouping problems because we have a coefficient other than 1 in front of the x squared. So I multiply 3 and negative 4 to get negative 12, and I ask myself what multiplies to negative 12 but adds to the middle term negative 4, so I'd be able to split it up. Well, negative 6 plus 2 would get me negative 4, so those are the factors I'm going to pick here. So I rewrite 3x squared. I split the middle term into minus 6x and plus 2x, and I rewrite my last term. Then I group. I take my first two terms, and I'm going to pull out a GCF of 3x. So I'm left with x minus 2 in the parentheses, and then I'll pull out a positive 2 from the next set. So I'm left with x minus 2 as well. When you're doing factor by grouping, these should always be the same factor. So I pull out an x minus 2 from both of these, and I just rewrite what I have left over. I've got a 3x, I've got a plus 2. And I'm going to set both of those pieces equal to 0. So x minus 2 equals 0, and I get x equals positive 2. And I set 3x plus 2 equal to 0. I subtract 2 on both sides, and I get 3x equals negative 2. And when I divide by 3, I get x equals negative 2/3. So I've said for all of these that you're able to check just by plugging your original left side of the equation into the calculator to make sure that it crosses the x-axis at 2 and negative 2/3. If you wanted an alternative way to check, you could always plug in these x values to make sure that when you substitute them back in, you get the 0 that you're hoping for. So when you simplify that, 3 times 2 squared minus 4 times 2 minus 4, you'll get 0 equals 0 to check that it is in fact a 0. Number 8, solve by completing the square. Okay, so the first step in completing the square is moving that c term over. So I rewrite my equation now by leaving a space on both sides where I'm going to find something that completes the left side to make it a perfect square trinomial. And I do that by taking my b term, negative 6, dividing it by 2, and squaring it. So negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. So I'm going to add 9 here and add 9 here. What multiplies to positive 9 and adds to negative 6? That's negative 3 and negative 3. So this factors into x minus 3 squared. And if you want a quick trick, the number that whatever half of b was is always going to be the number in those parentheses there. So if you want to skip the factoring step where you're thinking about it, you're more than welcome to. And 16 plus 9 is 25. If I'm trying to isolate x here, I want to get rid of that squared. So to undo a squared in an equation, I take the inverse operation and I do a square root. So on the left-hand side, I'm left with x minus 3. But remember, I need two solutions here. So square root of 25 is 5. So I'm left with plus or minus 5 on the right side of the equation here to make sure that I get those two solutions. So I keep solving this like a regular equation, and I get x equals 3 plus or minus 5. But the problem is that doesn't really show that I know what those two solutions are. So I'm just going to break that up into x equals 3 plus 5 and x equals 3 minus 5. So you get x equals 8 and x equals negative 2. As always, it's a good idea to check just by plugging that into your calculator, making sure those are the x-intercepts. Number 9. Solve by completing the square and express your answer in simplest radical form. So if they're telling me it needs to be in simplest radical form, chances are when I go to complete the square here and I add something to the right side and add something to the left side, what I get on this left side will be something that's a non-perfect square. So I'm going to need to simplify it a little bit as it's under the radical. So I do the same process as I've done before. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. So I'm going to add 4 here and add 4 here. This left side factors into x minus 2 squared equals 27. To undo the squared, I take a square root, and I'm left with x minus 2 equals plus or minus, don't forget that, you need your two solutions here, radical 27. And now radical 27, if I'm thinking about that, 27 isn't a perfect square, but I know two numbers that multiply to 27 where one of them's a perfect square, and that's 9 and 3. So if I break up radical 27 into radical 9 times radical 3, I have x minus 2 equals plus or minus. Radical 9 is just 3, and there's nothing I could do with radical 3 because it's already simplified and it's not a perfect square. Then I solve it the same way I did before. I add 2 to both sides, and I'm left with x equals 2 plus or minus 3 radical 3. I treat that radical 3 just like I would an x. If I'm adding 2 to both sides of the equation, if that was an x, I wouldn't combine it to make 5x or 5 radical 3. So just keep that in mind that if a number has a radical attached to it, we treat it as a separate term. And again, your last step is just to write it as two different solutions. X equals 2 plus 3 radical 3, and x equals 2 minus 3 radical 3. So if you know how to complete the square and you know how to simplify radicals, this problem isn't a whole lot different than number 8 that we just did. Number 10. Solve the following system of equations algebraically. So this is some sort of quadratic, and this is some sort of line, and I don't know how many times they intersect, so I'm just giving a rough estimate here. So I need to find some x values that are going to make the y values for both of the points of intersection, or one of the points of intersection, the same. So the process by which we do that algebraically is we start by isolating y in both of the equations. Notice that they're both isolated here. So I'm going to take this value for y, the 6x minus 14, and substitute it in to that y right there. So essentially, I'm setting the two equations equal to each other. 6x minus 14 equals x squared plus 3x minus 12. Now, in order to solve any quadratic equation, I always want to get it set equal to 0. So I'm going to add 14 on both sides, and I'm going to subtract 6x on both sides. So I'm left with 0 equals x squared minus 3x plus 2. Now, this is a best case scenario here because there's no number in front of the x squared other than a 1, so I could factor this how I normally factor a trinomial. I ask myself what multiplies to positive 2, but adds to negative 3. Now, if you think about that, if they need to add to negative 3, both of the factors for 2 need to be negative to ensure that they multiply to a positive but add to a negative. So it looks like negative 2 and negative 1 are the only pair that works here. So I rewrite it as x, and I plug in my two factors, minus 2 and minus 1. So when I tee it off, I get x minus 2 equals 0, and x minus 1 equals 0, and I get x equals 2 and x equals 1 as parts of my solution. Remember that when you're looking at a system of equations, you're looking for the points of intersection. So points of intersection have an x value and have a y value. Once we have our x values, we substitute them into either equation to get our y values. Now, I always pick the one that looks easiest to me, so I'm going to start with that bottom equation right there. So I'm plugging in x. So y equals 6 times 2 minus 14. 6 times 2 is 12, minus 14 gives me y equals negative 2 as one of my y values. And as I'm substituting in for my other one, 6 times 1 minus 14, 6 minus 14 equals negative 8. So your last step here is just to show that you know that these represent points. So when I plugged in x equals 2, I got negative 2 as my y value. And when I plugged in x equals 1, I got negative 8 as my y value. That's how I know which x value goes with which y value. Whichever one you plugged in, that's the one you're going to write next to that y value. So your solution for this set of equations is 2 comma negative 2 and 1 comma negative 8. As always, when you're doing things algebraically, there's always ways you could check yourself in your calculator. So all you would have to do is just graph both these into y1 and y2, and just make sure that these are the 2 points where the graphs cross.